So these are some of the ways that you can do. You can create your object. You can also use something called as mutable copy for strings. These are mutable copy. This method is present in some specific classes of the foundation framework. So you have NS string, NS array, NS dictionary. These objects, these classes have a mutable version and an immutable version. So by default, if you say NS string and you create a string from this class, you cannot change it. So mutable means it can be changed. So for that, the corresponding class is NS mutable string. And so similarly for array also, it is NS mutable array. Okay, and if we go, if we look at the init alloc here, the init function here, this is called as the initializer. Now, just like Java or any other language, you can also have your own initializers. So, for example, you can extend this and say init with certain parameters. So, which in NS string has that function. Okay, let's just use this. Init with string. So it's nothing but just takes an input string and it creates a variable, string variable, right? So what is this init with string? This is an initializer which you have extended from the basic init initializer. And init, this method is it's an object method, meaning you have to have an object and you can call this method only on that object. And it returns a, okay, I'm just taking you to the class reference. Okay. Yes, the init function here. So this is what we're talking about. This is the designated initializer. And this init itself comes from NS object. So if you see, NS string is a subclass of NS object. And the way it is defined there, yeah. Okay, so basically, if you see the documentation, for NS object, okay, right, so this is the method, right, so it actually returns an instant type, but this instant type is of type ID, right, which means, and we have seen what ID means, right, it is basically a pointer to any kind of class. So we have not typed it to NS object. And this is because every object, every class that extends from n as object will have access to this. And so it does not make sense to typecast it. And hence this is the return type is simply ID. So that's the important thing to remember here, and that's the reason why I wanted to show you using log. So these are some ways of creating objects. But the most underlying thing that you need to remember is when you create it with init, it calls a instance method of and it returns a pointer to of type ID. And the other thing to remember is designated initializer. So by default, you will get the init initializer by virtue of it being from n as object. But you can also go ahead and write your own initializers like in Java or any other language, any other OOPS language, sorry. And what you will do is the way you will identify it as a designated initializer is using this syntax here. Instance type, values, so using this macro or this predefined setting, you can create a designated initializer. Now of course you have to follow the same syntax for any other method, and you have to override it in your implementation file. Now the other ways of doing it is by accessing it from any other object. So for example, an NS string can also be created by accessing an object in the NS array object. So NS array is a collection of objects, and there are methods in NS array saying last object. Now this object typically outputs is of type ID, simply because at the time of compilation we will not know what is the type of the object. So and hence the return type is ID. And object at index is a specific the object at a specific index. Now objects can also be created with certain initial values, like I said. So NS number already has an implementation for this kind of initializer. It says init within 27. And arrays can also be pre-filled with some objects, init with objects, but always end it with a nil. Okay. Now dynamic binding is very useful, but it also has its own pitfalls. So basically, ID indicates the type of the object, or it's a reference or a pointer to an object. So if you would have noticed, there's no pointer. There's no asterisk here. This is because ID has already been defined as a pointer variable. So you do not go ahead and simply again notify it as a pointer using an asterisk. So so at compile time, yeah, so at compile time, there's no way for the compiler to know whether the assignment is, valid or not valid. So it will go ahead and it will create it. But at runtime, this may not be the case, right? What you have expected the object to be may not always be that. Okay, I have got a question. Can you please once again explain NS designated initializer? Okay. So, okay. So basically, NS. So what a designated initializer is? See, when you have a class, when you have defined a class, when you have created a class, right? You can have, many methods. You can have, and out of these you can create your own initializers basically. So you can have instance type init with greeting, you know, or you can have, so it's really up to you how you know, strongly you want a control over your class. So you have created a class and you have given it to the world to create objects from. So then you ensure that certain things are set in your class, right? So that's the reason you create initializers, which are not over and above the init function that NS object provides for you. Now, out of all these initializers, how to ensure, how to set one as the designated initializer? So this macro lets you do that. So it's a notification saying that this is the designation initializer. Okay, great. Okay, so we were here, right, in the main file. Yeah. So ID lets us do dynamic binding, but there's no way for the compiler to know if it's been cast correctly into the correct object. So we have to be careful. We have to judicially basically use ID pointer. We have to use it judicially. So when you typically assign a pointer to an object, say ns string s is, you know, the object, the address of the object. So if you say @, it's the address of the string object which has been created. Okay, so this is statically typed. So the compiler knows that, you know, the string pointer has been assigned, a string pointer has been assigned, and it's pointing to a string object. That's fine. But in case of ID, like I said, there's no way to actually find out. So this is not statically typed, but it's perfectly legal. But this could lead to runtime problem. So for example, this person, what he's done is he has pointed this obj pointer to a string object, but then it has been assigned, so an ns array pointer has been assigned this. So now obj is pointing to a string object here because of this, and then another array pointer has been created and it's been equal to this. So obviously this is going to crash. This is not correct. Okay, so but then this is static typing. And also methods, there are other methods that support static typing, of course alloc init, and array with objects, array first object. So here you have an array which is filled with numbers 1, 2 and nil, and then this ns string, there is a string pointer, so which points to the first object, right? Okay, so let's just go and create an array. Now I'm trying to output this, okay? So because I know this is a string, I'll pass in the format specifier as %@. This is a format specifier for string. For integer, it's d, and so on and so forth. So just go and say str from array. Okay, so it's pointing out gamma as the last object, so it's given me that because it's assigned it there. Okay. Now here quickly I'd like to just run you through this part of the statement output in the output console. So this you can see is a timestamp. This is the name of the product, and this here is the process ID and the thread ID. So in case you are trying to create multi-threaded programs, this is a check for you to understand, identify the threads based on the IDs. Okay. So now in our case, what we've done is we have created an array, and now let's see if we can typecast it to an ID object. We're not typecasting, we're just allocating ID pointer to one of these objects. Okay, so let's just say ID obj is equal to arr1. Let's just call the object at index and say 0. Okay, so 0 means it's like in an array, it's the first element. Let's just run this again. Okay, sorry, I did not log it. Okay, so it gives me alpha. Fine, because object at index, this method anyway, it gives me an ID object, right? So now let me go ahead and say ns number. One. Okay, and put this as an ns integer. Okay, it says incompatible pointer types because this is returning an ID, so it cannot work with ns integer. Okay. So let us say okay, great. So so what it's gone ahead and done is, because I've performed a format specifier here, it's giving me some unpredictable results. So we need to use the date format specifier. So let's just leave this for now and then come back to this later. Basically, what you need to understand is that ID static typing lets you do this, and the compiler will warn you regarding what is legal and what is illegal. Okay. Okay. So now let's take an example. Let's create two classes, a rhombus and a circle. And these have functions for calculating the parameter and printing it. Obviously, the implementation is different based on the formula for a rhombus and for a circle. Okay. So let's go back to Xcode and Yeah, here I just wanted to quickly show you str1. So how a string by appending works. So let me just quickly run that for you. Yeah, so basically it's put in a new line and then added best wishes because str object initially did not have anything. So it's combined null with say best wishes. So if we were to say, let's just assign this last object to strobj. So what we've done is we have created strobj. We've also created an array with some initial values, and we have extracted the last object from the array and assigned it to a string. And then we have created another string by appending some message to the first string. So let's just see what it outputs. Just says gamma, new line, and best wishes. So this is how this string has been created. Although it's not used any initializer, it's been created using this method. So these are called as convenience constructors. And how they work in Objective-C is that internally they will go ahead and they will call the init method. So till it reaches the, in the hierarchy, till it reaches the root initializer of the root class, it will transcend all the, hierarchy, object hierarchy, and then from there it will implement it, and then it will come back and it will implement the other convenience constructors and say based on, certain extra implementation that has been written in these constructors, some values will get set. So that's how, so internally everything goes back to init. So that is the bottom line. But these terms you need to know: designated initializer, convenience constructors, and so on. Okay. Okay, so we'll go ahead and we'll create, okay, we need to close the simulator. So for that we just click on the square button to stop. Now click new file. Okay, so I have created this shape file here, right? Okay, it extends from ns object. And for now, we'll just have an empty file. Now circle and rhombus will be extending from the shape file, from the shape class, sorry. Circle, shape. I'll just place them together. Yeah. So if you see the header file of rhombus and circle, they both extend from shape. Okay. Okay. So now what I'll do is I'll just quickly create two methods. Since it's a primitive data type, you need not give the pointer. Okay. And now in the implementation of rhombus, I'll implement these two methods. See, I get the signature automatically. Calculate perimeter, and perimeter is okay. So before that, I have to now perimeter is 4 times input. Okay. So since it's a float, this is the format specifier, and I'll put the perimeter. I'll point it to the perimeter. Okay. Similarly for circle, then circle's implementation file, I'll similarly create a method. Okay. But here the formula is going to be difference 2 pi r. This is a pi, and yeah, I will change this. Okay. And now in my main file, I'll call these two classes and their methods. So for that, I need to import these two files. Okay. I will go ahead and create these two objects. Please keep doing this exercise with me, because you need to still get used to Xcode, and if you're doing it in the class, you can also ask me questions. Okay. So once I've created these two objects, I'll call their methods. Let me pass some number. Okay. Now let's see what happens when we run this. Okay, let me just So now let's just create an array again and say shapes. Let's call it shapes. And then we'll add these objects inside. Alloc init with objects, and the first one would be circle followed by rhombus and nil. And now we already saw how we call the last object, or objects at a particular index. So we will say last object. Let's just call the first object. So now what we're doing is we are taking one of the objects from the shapes array and assigning it to object 1, which is an object pointer. But then we are going ahead and calling the calc function on this. So let's say we'll pass this. Okay. So if you notice, the compiler does not still know that object 1 is of class circle, but still it lets us go ahead and call this. It even gives us a reference to this because there's a known declaration of this, in all these header files that you see. So there's somewhere it gives me a match. So it lets me do that. The compiler will let me do that. Now let's go to ID object 2 last object, and I again call the object 2 calculate parameter and again pass it 20.0, right? Okay, so okay, so if you see, okay, let me just go ahead and type. Yeah, so if you see, it has still gone ahead and called the correct methods for each. So it knows that rhombus is object 2 and circle is object 1, and it's gone ahead and although they were typecast to ID, in shapes array they came out as ID, but still it has gone ahead and invoked the correct functions for each. So that is how dynamic binding happens in Objective-C. Right. So yeah, so okay. So now we see other examples where we would use this. Right, like in a collection like an array, there's no idea of the objects which are there. They can be mixed. So this helps, dynamic binding helps us in such situations as we saw. It also helps us in MVC because in that case the controller needs to call classes and needs to invoke methods on both the model and the view. So it will not necessarily know the type of each. The disadvantage, excuse me. Yeah, the disadvantage is that you cannot find the errors in the code during compile time. Okay, so now how to find the middle ground between this? So either you have to strongly statically type them into distinct classes, or if we let them loose, then we have potentially dangerous situations situations during runtime. So the middle ground for this is where we come across these two concepts, introspection and protocols. So what are these? Okay, introspection is like reflection in Java. Basically, you try to find out what is the underlying type of the object, what is the class of the object. And this you do by invoking, certain methods. And you also do it to find out what are the valid methods present. So if it is an object of a particular class, then you will know that the methods of the class can be called on this object. And all this introspection is done at runtime. So that is one way of doing it. Second way of doing it is using protocols. So what protocol says is it is an ID, so it can be any object. But when I say my object, my scroll view, for example, in this example, you say scroll view delegate is of type ID. So it can be any object. But it conforms to this protocol. So when you say it conforms to this protocol, that means it still has to implement or follow certain methods. So it will have the implementation of methods which have been defined in this protocol. So when you define a protocol, you will give the declaration for certain methods. And all objects that conform to this protocol should implement these methods. Right? So these two ways, by these two ways, you are still, guaranteeing a certain amount of safety and ensuring that your application does not crash during runtime. Yes, there are situations where you don't know where your objects come from. So static typing will not help. There are situations where you need to give flexibility, but at the same time have a certain amount of security. So how do you do this? Using introspection and using protocols. Protocols you do at compile time during coding, and introspection you do during runtime. Basically, introspection is like a check. So let's look at these two in detail. Okay, so introspection is, like I said, the ability to find details of the class, its methods, and its properties. And how do we do this? We have methods for this. And these methods are is kind of class, is member of class. These are two important methods. So is kind of class will also include the superclass. So if you say, if you say is kind of class n is object, then every object will say true because they all derive from that. That's not a good example, but say in our case we can say is kind of class shape. Then in that case, the first object in the array would return true. Whereas this member of class is more specific, so it will return true only if it is circle. Then there are methods, messages which you can use to see if the object, underlying object, the unknown object responds to. And the method name is response to selector. So here we pass the function name. So what is a selector? Selector is a keyword in Objective-C, and it means the method name. So what we will do is we'll pass the method name, response to selector, say in our case it was calculate parameter, right? So we can do that, and then we can check. And third is conforms to protocol. So when you say conforms to protocol, it means that this object has implemented the methods which have been defined in that protocol. Okay, and where do these methods come from? Basically, they come from the NS object protocol. So you have NS object protocol and NS object method. Let us see. So earlier when I pulled up the NS object, I got both. Protocol, if you see there's a PR here, you can simultaneously look up the documentation in your respective Xcodes as well. Okay. And the second one is the class. So let's check NS object protocol. Yeah. And the classes here are what you see is kind of class, is member of class, responds to selector, conforms to. So all these methods have been defined in this protocol. And since NS object class implements this protocol, or it conforms to this protocol, therefore it has already implemented these methods in the framework. So you do not have to go ahead and implement these methods. And that's how you get access to them as well, to check for introspection. Okay, so these are the ways by which you can use these methods. So like I said, you can first check if the object responds to a selector of that name.